Hello, everybody. I'm Dennis Farley, and want to just very briefly explain a few improvements that we've made to the insulation capabilities, and there's three of them. We implemented the grade 1, 2, or 3, which is the quality with which Batt insulation is installed. And we also have accommodated now a void fraction for loose fill insulation. And we're also accommodating compression of batts into a wall cavity that's smaller than the natural size of the batt insulation. So there's a list of those three. The installation grade, we use a system that's defined in the ResNet standard, grade 1, 2, and 3. And for voids and loose fill, we're representing that according to the void fraction. And for Batt compression, we're using the guidelines from HUD or Manual J. So for those who are not familiar with the grade 1, 2, and 3 quality of Batt installation, this system quantifies based on workmanship of how well the insulation is fit around things like water pipes, conduits, electrical boxes, in terms of the amount of void that's created and also compression of insulation. And if you are not familiar with that and want to become familiar, this first reference is there we go, that's better. Steve Baden's slideshow that he gave to an Energy Star conference has illustrations that show the difference between what grade 1, 2, and 3 mean. Grade 1 is the best, grade 3 is the poorest. And by the way, Energy Star cites ResNet procedures on this, so we're consistent with both ResNet and Energy Star. The actual documentation that defines the criteria for grade 1, 2, and 3 and prescribes the rules by which they should be modeled is in the ResNet standard. And those documents are available online. If you just Google the titles, they're pretty easy to find. They're at the ResNet website. So this is what the option screen looks like for the stud wall options. And the two that I've highlighted are examples. So this option 6 is R11 batts grade 1 in 2x4 studs, 16 inches on center. Option 7 is R13 batt grade 3. And if you look at the next column where the assembly R values are shown, you can see that R11 grade 1 is actually better than R13 grade 3. So that gives you some idea about how much difference this makes. If you go into the option editor to create some new options for wall insulation, you will run into this little pull-down menu. And if you're entering the batt insulation, you'll select grade 1, grade 2, or grade 3, and BEopt will adjust the assembly R factor accordingly. If you're entering a loose fill option, you would pick not applicable for the grade, and then you would enter the void fraction in another cell. It's one or the other, not both. So for void fraction, we model that portion of the wall as R0 insulation. In other words, it's an empty cavity with just the resistance of the air gap in parallel with the insulated portion of the cavity. So here are the two options that I've highlighted are R13 loose fill, and one is with 5% void and the other one is with no void. And if you look in the next column at the assembly R factor, it makes a difference of about R1 there, so you get an idea of about how much difference that makes. And then the third adjustment that we've made to insulation is compression of batt insulation, because this would be over the entire cavity area because the batts are larger than the size of the cavity. So for example, in the walls, R19 in 2x6 studs is derated to R17.3, and also in cathedral ceilings, where batts are fit into a confined space, derating supply there. And the sources that we've drawn on are the HUD standard and Manual J, which is cited by ResNet. This is not automated in BEopt. These are entered on a case-by-case basis. So if you were entering some new options, you would probably want to look in one of the references to figure out the appropriate R value to use.